Hello again. In the previous video, we took a look at how to get some big benefits from the JIT version control system with minimal effort. In this video, we're going to look at Python's built-in venv tool, which allows us to keep our programs and their dependencies separate from each other, and the software installed on our overall system. When we're working on a project, we'd usually like the parts of the project that aren't our own code to stay the same. We might have a good reason to install a new version of Python or an updated library on our system. But we don't really want those things to change within our development environment. Even more so, we can easily find ourselves targeting entirely different and incompatible system configurations with different projects. We need a way to set aside an area for each project that is separate and can be configured for the specific needs of that project. That's what we call a virtual environment. And the venv tool that's built in to Python 3.3 and later creates them for us. Each virtual environment created by venv knows which version of Python it should be using and has its own package library, which means that as far as Python code is concerned, it's basically disconnected from the rest of the system. We can install, uninstall, and update packages on the system, and the code inside the virtual environment won't even notice. We can install new versions of Python, and the code inside the virtual environment won't notice. About the only thing we can't safely do at the system level is uninstalling the version of Python that the virtual environment is based on. It's easy to create a virtual environment for a new project. We just open the command line and go to the folder where we want the project folder to reside. Then, we use the version of Python that we want the virtual environment to use to run the venv tool. When we call venv, we tell it the name we want to give to the project folder. The venv tool will create the project folder and populate it with the files needed to support the virtual environment. Each time we actually want to work inside the virtual environment, we should activate it. That will make whatever changes are needed so that the contents of the virtual environment override the system-level defaults. To activate a virtual environment, we open a command line and go to the folder containing the virtual environment, then execute the activation command. The specific activation command we're using depends on the operating system. On most Unix-style systems, including Macintosh, we use the command source bin/activate. On Windows, we run scripts /activate.bat. When we're operating inside an activated virtual environment, pip automatically knows it should manage packages for that environment. Initially, the virtual environment contains only the Python standard library and a couple of utilities, including pip itself, but we can use pip to install the third-party packages that we're going to use on the project. When we looked at pip, we learned about its -- user command line option, which installs the package into a personal package library instead of the system library. That's never necessary when installing into a virtual environment because the virtual environment has changed where the default installation location is. Now that everything's set up, we can begin work. We shouldn't delete any of the files or folders created by venv or pip. But other than that, we're free to create files and folders as needed for our project. It is often useful to create a subdirectory to contain our working code. In this video, we learned how to use the simple but useful venv tool to isolate our coding projects from each other and from most changes to our development system. Now that we've seen all that, we're going to take a closer look at doc strings. In the next video, we'll learn how to structure our doc strings for maximum utility, how to add rich text formatting to them, and how to export them into hyperlinked HTML documentation for viewing in a web browser.